Let's go on in section 1.5 and let's work a couple more word problems. Remember, in each problem we want to set up a quadratic equation to model the situation, and then we can solve that equation and answer the question that we're given. Here in number 3, it says a landscape architect has included a rectangular flower bed measuring 9 feet by 5 feet. She wants to use 2 colors of flowers in the bed, one in the center and the other for a border, and the border has the same width on all 4 sides. If she has enough plants to cover 24 square feet for the border, then how wide can the border be? Well, a lot of times the best way to start a problem like this is to draw a picture. And so I've already started here, and I've drawn the big rectangle and a little rectangle inside. Can you see what the length of the large rectangle is? It's 9 feet. And the width of that rectangle is 5 feet. And then there's one color of flowers in the middle of the large rectangle, and so that's the smaller rectangle. And then there's a border which has the same width on all 4 sides. And so what that means is that this distance here is the width of the border. We don't know what that width is, so we'll call it x. And it's the same width on all 4 sides, and it would probably be good if we go ahead and label it on all 4 sides. And so now we know that she has enough plants to cover 24 square feet for the border. So the area of the border is 24 square feet, or the area of the border is 24. And so can you see how to set up an equation that says that the area of the border is 24 square feet? What we want to do is we want to compare the area of the large rectangle and the smaller rectangle. So the difference of those 2 rectangles is the area of the border. So the area of the large rectangle, I'll abbreviate rectangle, minus the area of the smaller rectangle is the area of the border, is that 24 square feet that's left over. Okay, and so what's the area of the large rectangle? That's just length times width, 9 times 5, or we could go ahead and write 45. The area of the smaller rectangle is a little trickier, and so let's think about it here. What we have here is 9 feet for the large rectangle. We need an expression for the length of the smaller rectangle. So what we're going to say is that if we start with the 9 feet and then we take away an x, a length x on one side and a length x on the other side, then that gives us the measurement that we need. So we're going to have 9 minus x minus another x, which is going to be 9 minus 2x. And then similarly, for the height of the smaller rectangle, we'll start with 5, and then we'll subtract off 2x from that. that's a little tricky to set up. You wanna think about that, and hopefully you'll see a problem similar to that in your homework. Okay, so we can go ahead and now that we have the quadratic equation, we can go ahead and work through it and solve it. And so we'll let's go ahead and do 9 times 5 is 45, and then let's distribute the two binomials here, and let's leave it inside the parentheses, and we'll distribute that minus sign in just a minute. So that we're very careful with the signs. So we have 9 times 5 is 45, and 9 times minus 2x is minus 18x. Minus 2x times 5 is minus 10x. And then minus 2x times minus 2x is plus 4x squared. And then all of that is equal to 24. Okay, so now we can distribute the minus sign. We'll get 45 minus 45 plus 18x plus another 18x, plus 10x this time, and then minus 4x squared. And all that's equal to 24. And let's keep going. So 45 minus 45 cancels. The minus 4x squared, I'll go ahead and write that first. And then 18x plus 10x is 28x. And that's equal to 24. And so now things are looking a little better. We can go ahead and set our equation equal to 0 and try to factor it. Minus 4x squared plus 28x minus 24 is equal to 0. And then notice two things. Notice each of the constants here is a multiple of 4, and so we could divide through by 4. And the other thing that we'd like to do is we'd like to have the leading coefficient be positive. We don't want to factor with a negative on the x squared. And so let's divide through by negative 4, and that's fine as long as we do it on the other side, which of course doesn't change the other side, it's still 0. So we get x squared minus 7x plus 6 is equal to 0. And then that's a nice little quadratic. We can factor that. Take a little extra time to factor it on your own if you like. If you need a little extra time, maybe you already see that you're going to get x minus 6 and x minus 1. And so we have two solutions. We have x equals 6, x minus 6 equals 0 gives x equals 6. Or the other factor, x minus 1 equals 0 gives us x equals 1. Now we need to make sure that we're answering the question completely. So let's go back and make sure we know what the question is. In number 3, it says, how wide can the border be? And so that is the distance x that we just found. And then we've got two answers. X could be 6 feet or x could be 1 feet. How do you feel about those answers? Well, if you look back at the situation here, the entire bed is only 9 feet long. And so if x were 6 feet on either side, on one side and then on the other, then there wouldn't be any room. That would be 12 feet of border total, and there wouldn't be any room left over for the flowers in the middle. So that wouldn't make sense, and so we have to throw it away. X can't be equal to 6, and so the only reasonable answer is that the border is exactly 1 foot. Okay, that's a good one. Let's go on and do one more here. Number 4 says a kite is flying on 50 feet of string. Its vertical distance from the ground is 10 feet more than its horizontal distance from the person flying it. Assume the string is being held at ground level and find the horizontal distance from the person and the vertical distance from the ground. Okay, so once again, drawing a picture would be very helpful, and so we'll start like that. A kite is flying on 50 feet of string. Maybe we can imagine the kite blowing in the wind a little bit. I'll put K up here for short, for kite, and we know that this is 50 feet of string here, and we know that the vertical distance from the ground to the kite, the vertical distance from the ground to the kite, that's the vertical leg that I just drew, is 10 feet more than the horizontal distance from the person flying it. That would be this horizontal leg over here. And of course what we have is a little right triangle. And so the vertical distance is 10 more than the horizontal distance. We can write x for the horizontal distance and x plus 10 for the vertical distance. And I think our picture looks pretty good. It says now find that horizontal distance and that vertical distance. So do you remember a formula we could use here? This is a right triangle. And we're talking about a relationship between the sides of the right triangle, and so I bet you're thinking of the Pythagorean theorem, which says that a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse, in this case 50. So we'll replace a with x, and we'll replace b with x plus 10, and we'll replace c with 50. And there is our quadratic equation that we can solve to answer the question. We need to distribute x, we need to multiply out x plus 10 times itself, and so we'll get let's see here, x squared plus 20x plus 100. Sometimes students forget about that middle term, so don't forget. Actually write out x plus 10 times x plus 10 on the side and make sure you see the middle terms. Okay, that's equal to 2500. And now we can combine x squared plus x squared is 2x squared plus 20x. Could we just go ahead and subtract the 2500 over and get 100 minus 2500 is minus 2400. And now we've already got our equation set equal to 0. We can divide off a common factor of 2. And we've got x squared plus 10x minus 1200 is equal to 0. Okay, that is probably not too hard to factor. Maybe it's a little tricky just because 1200 is such a large number. So if you're stuck on the factoring, if factoring isn't working for you, then just remember, just use the quadratic formula. And you might like to do that anyway, just for a little extra practice and just to confirm that you get the same answer either way. So let's see here, 30 times 40 is 1200, and the difference between 30 and 40 is 10. So that should work. We just need to make sure that we have our signs right, that we have a positive 40 and a negative 30, and that'll do it. So x plus 40 times x minus 30 is equal to 0. Set each factor equal to 0 and solve, and we get x equals negative 40 or x equals positive 30. Once again, just like in the previous problem, we need to make sure that our answer is reasonable. If we go back up, remember we're talking about distances, horizontal and vertical distance. And so those are, distance is a positive number. And so the negative 40 doesn't make any sense in that context. So we have to throw it out. And then we can say there's only one answer, and that's for the horizontal distance to be 30. And make sure we've got the units feet. And then the vertical leg would be x plus 10 or 40 feet. So this is the horizontal leg or the horizontal distance, and this is the vertical leg or the vertical distance. And we've got our answer.